Hello friends, I welcome you all to the course on automation in manufacturing. Well, we are starting the week second. The lecture 1 of week second is on mechatronics based systems. The outline of this lecture is as follows. At the start of the lecture, we will study the definition of a system, the meaning of the term system, which is often used in automation and in mechatronics based systems. Then we will have an example of a system. We will be studying a simple mechanical element, that is spring. A mechanical spring will be studied to understand the meaning of the term system. Then we will see what is the meaning of mechatronics based automated system. We will see what are its building blocks, and at the end of the lecture we will study how to develop an equivalent mechatronics based system. Now till now we are using a term or a word very regularly, and that term is system. So as far as engineering point of view, we can define a system as a box or a bounded hole or volume which has certain inputs and certain outputs, and there is a set of relationships between these elements. So these elements are input and output. The set of relationship between the input and output is representing the behavior of the real system, and when we represent this relationship in mathematical form, then we are calling that process as the modeling of the system. So simple example of a system is a thermometer. Thermometer is very common system that we do have. So thermometer, the input to the system or input to the thermometer is temperature. So thermometer measures the temperature. So the input element to this system is temperature, and what we get from this thermometer is a value, and that value is, or a number is displayed on the screen. If it is a digital thermometer or if it is analog thermometer, then we can see it on scale. So there is a relationship of this number with this temperature. As the temperature is increasing, the number is also increasing. So I can say the number displayed on the screen is directly proportional to the temperature. So that is the relationship. So this relationship, when we represent mathematically, then we are calling this as the modeling of the system. Second example, you can have a motor. For motor, the input is electrical power and the output is rotation. Again, there is a relationship. The rotation of the shaft of the motor will rotate at a high speed when more electrical power is applied. So the motor or a thermometer can be called as systems which are having certain inputs and certain outputs. Let us take one more example of the term system. So on your screen you can see a typical mechanical system, and that typical mechanical system is a spring. The spring is widely used in variety of engineering applications. The most important or the most common application of spring is in suspension of automotive. The springs comes into a variety of types such as compression spring, extension spring, torsion spring, coil spring and leaf spring. Moreover, we have also seen one application of the spring in our previous lecture, that is in watches or clocks. Now on your screen you can see a typical spring and a force arrangement. So in the spring, so when we apply a force at the free end of the spring, its end will get displaced. So, the input to the system is a force and the output is the displacement. The spring follows the Hooke's law. So, Hooke's law is a principle of physics. So, that states the force needed to extend or compress a spring by some distance is proportional to that distance itself. So, this law was given by a British physicist in 17th century. When a spring is stretched or compressed so that its length changes by an amount x from its equilibrium length, then it exerts a force, that is F, in the direction towards the equilibrium position. The force a spring exerts is nothing but the restoring force. It restores the spring to its equilibrium length. So, if we try to write this Hooke's law, it simply F is equal to kx, where F is the force in Newton, x is the distance in meters, and k is the constant of proportionality, and it is called as the stiffness of the spring. The same spring system, the block diagram of a typical spring system can be seen on your screen. So, as you know, it has a force and it has the displacement, and it follows the principle of operation as F is equal to k into x. So, this F is equal to k into x would be true in the case of steady state condition. However, in reality the spring will oscillate, spring will vibrate about its equilibrium position, and it will achieve its equilibrium position after certain time. So, if I say, if we apply a force on the spring, if I say I apply a force on the spring, and if I try to observe its extension, so we get the extension of the spring. However, this will not be the final extension or final value that we will be getting. The spring will oscillate and vibrate, and after some time it will get stabilized. Now, let us see what are various building blocks of a mechatronics based automated system. The first building block of an automated system is the measurement system. So, measurement system has various sensors, signal conditioning devices, and display units. The second building block is the drives and actuation systems. The third one is a microprocessor system, and the fourth building block is the software. So, as you know, software is a set of programs which are controlling the operations of the microprocessor system. Well, if you try to develop an arrangement showing the building blocks of an automated system, so we can see here a mechanical system which is basically being controlled by a microprocessor based control system. So, this microprocessor based control system gets inputs from various sensors. That sensors may be digital sensors or analog sensors. These sensors are further giving signals to signal conditioning devices. So, the signal conditioning may be conversion of analog signals into digital signals. It may also have the various functions like amplification, linearization, noise removal, modulation. So, we will be seeing this signal conditioning in our next lectures. Then the microprocessor is giving signals to the actuators through a set of signal conditioning devices. So, as we know, the microprocessors are producing a series of pulses, and based on that series of pulses we have to actuate the actuators. However, some of the actuators are using the analog input as a motor. In this case, we have to convert the digital signal which is coming from the microprocessor into the analog form, and that analog signal will be utilized by the actuator. Actuators are actuating the mechanical system. So, this is a typical arrangement in which we are having basic mechanical system, and this is being controlled by a microprocessor based control system, and it has the important blocks. They are the measurement system and the actuation system. So, we will be studying all these building blocks one by one in this course. So, to understand these building blocks, let us take a very simple example, that is spring system, which we have already seen, and let us try to develop an equivalent mechatronics based automated system for the spring system. So, here I am considering the spring as a model, and that mechanical system model we have to convert into mechatronics based system model. So, for this purpose I am considering a hydraulic piston cylinder device. So, as you have seen in spring, we have to mimic the Hooke's law, that is F is equal to K into X. Whenever we are applying a certain force, we are getting the displacement. So, to have an automated system, here I am taking a hydraulic piston cylinder device. It is having a cylinder, the cylinder has a piston, the cylinder has two ports, port number 1 and port number 2. So, when we apply pressurized fluid through port 1, there is an extension of the cylinder, the piston will come out of the cylinder. If we apply pressurized fluid through port 2, then there is contraction of the cylinder. So, piston will move inside the cylinder. So, this is a typical hydraulic piston cylinder device. When we apply fluid pressure, is a function of force F, then we will get the extension of the cylinder. So, this is the extension of the cylinder X. Then to make this process in an automatic way, we need sensors and a measurement system. Then we have to take the decisions automatically. So, for that purpose we are using a microprocessor. So, my microprocessor is nothing but a device which is having logic gates and memory elements. A microprocessor is nothing but a collection of logic gates and memory elements. So, microprocessor carries out logical functions which are implemented by means of software. Consider we might want an output if input A and input B are both giving signals. We want an output when input A and input B both are giving signals to microprocessor, then we want to have the output. There may be a situation or there may be a program which is asking the microprocessor to produce output when either of input is present. So, these type of conditions, when the microprocessors are taught through programs, then we are saying that we are developing a microprocessor based control system. When the input output ports, memory and all logic gates are integrated on a single chip, that is called as microcontrollers. An embedded system is a microprocessor based system that is designed to control a range of functions and that is not designed to be programmed by the end user. So, we often using a term embedded systems. The meaning of embedded system is that when the microcontrollers or the microprocessor based system is integrated to the mechanical system and the end user is not allowed to program it. So, simple example is washing machine. So, we cannot reprogram or we cannot edit the program of the washing machine. So, whatever the designer or the manufacturer has given to us, so we have to use the same program or the same mode of operation. Then the next building block is generation of signals of appropriate level and of suitable type. Then actuation. So, the actuation, as we have seen, it is nothing but the extension on or the contraction of the cylinder. So, this extension or contraction of the cylinder would be done by using pressurized hydraulic fluid. That pressurized hydraulic fluid will be generated by using an electric motor and hydraulic pump arrangement. So, pump and motor arrangement are the actuation devices, and then we need to write a computer program. We need to write a set of instructions which are mimicking the Hooke's law. So, let us represent all these elements as a block diagram. So, we have taken the hydraulic piston cylinder system, then we have to select suitable sensor. In our case, we are taking LVDT, that is a linear variable differential transformer. It is contact based displacement sensor. The sensors are producing the signals, that signals will be conditioned and the analog form will be converted into digital form, and that digital signals are given to microprocessor. As you know, the microprocessor understand the digital form of the signal. So, what is the meaning of analog form of the signal? In analog form, the signal is continuous function of time. So, that is the analog form. However, in digital form, the signals are nothing but sequence of pulses. So, we are getting the signals in terms of pulses, or sequence of pulses is nothing but the digital input. Microprocessors, they do understand the digital signals only. So, that is why we have to convert the analog signal into the digital form. Microprocessor has the program set by the programmer. It generates the output into the digital format, and that output we need to further convert into analog format, because our actuator is an electrical motor. So, the motor is running based on the electrical power. So, we have to convert the digital pulses into appropriate level of analog signal, and that analog signal is actuating the motor. Motor is driving the pump, and the pump is driving the hydraulic piston cylinder arrangement. So, it extends or contracts based upon certain arrangement of motor, pump and few other auxiliary equipment, and based on that again it generates certain signals at linear variable differential transformer sensors. That sensors are giving input to the microprocessor. Microprocessor again process the information and take the signal and give to the hydraulic piston cylinder arrangement. So, in this way it is easy for us to mimic the Hooke's law, that is F is equal to K into X. Now, based on the, let us try to see how can we have the actual arrangements of all these elements. So, on your screen you can see a typical arrangement that can be developed to mimic that the Hooke's law. So, in this case if you want to convert this equivalent mechatronics system into an actual mechatronics based automated system, what are the various things are required? So, that we will see. So, on your screen you can see a typical arrangement. So, this typical arrangement has the hydraulic piston cylinder arrangement. At the end of the piston we are attaching a plate. There is a set of sensors, LVDT sensor 1 and sensor 2. Sensor 1 will sense the extension of the cylinder, sensor 2 will sense the contraction of the cylinder. Analog to digital converter, microprocessor system, digital to analog converter, and the microprocessor of the system is controlling the operations of the hydraulic pump. The processor is giving signals to pump, it is starting the pump and it is switching off the pump. The system is also regulating the pressure inside the system. The processor is also directing the flow of fluid inside the system. The microprocessor is also monitoring the quality of the hydraulic fluid which is being used by monitoring the signals coming from the filter. If the fluid is contaminated, if it has many physical particles that may clog the system, that may harm the system, then the microprocessor will give the alarm. It will ask the operator to change the fluid. Now, you can see how the microprocessor may operate the piston cylinder arrangement. For the extension, the microprocessor will give the signal to the hydraulic pump to pump the pressurized fluid at port A. So, as pressurized fluid comes through port A, the piston will move away, it will come out, the cylinder will extend and that will be sensed by the LVDT sensor 1. LVDT is in direct contact with the end plate. The sensor input will be used by the microprocessor, and if the displacement is as per the desire, it is fine. If it is not as per the set value, then it will ask the hydraulic pump to pump more fluid at port A till it achieves its designated value, set value. To change the direction of the piston movement or for the contraction, then the microprocessor may ask the control valve to put the pressure on the other side of the piston. So, for that purpose, the control valve will be operated by the microprocessor and the pressurized fluid will be given at the other side of the piston. So, when the pressurized fluid come in this area, then the piston will contract till it achieves its designated position. So, in this way the microprocessor controls the pumping of the hydraulic fluid inside the piston cylinder arrangement, it regulates the pressure and it controls the direction of movement of fluid inside the system. So, in this way we can convert systems into a typical microprocessor based automated system. Of course, for this we need many equipment, many sensors, actuators, and we have to learn how to program the microprocessors as well. So, with this discussion I would like to conclude this lecture. Well, my friends, let us summarize this lecture. We have seen in this lecture the meaning of the term system. We understood the principle of working of a mechanical spring in the perspective of the term system. Then we have seen what are the various elements of a typical mechatronics based system, various building blocks, and at the end we have seen how to develop an equivalent mechatronics based system. So, to understand the equivalent mechatronics based system, we have converted the concept of a typical mechanical spring into an hydraulic piston cylinder based arrangement. In the next lecture, we will study the definition of flexible manufacturing system, the meaning of flexible manufacturing system, various automated equipment which are used in the FMS. The FMS has the comprehensive use of CNC based technologies, conveyors, that automated conveyors, automated guided vehicles, automated storage and retrieval system, automated inspection devices. After this, we will study the CNC technology that is being employed in the manufacturing domain. To understand the CNC technology in a better way, we will be taking an example of a vertical milling process, a manufacturing process which is widely used in the tool rooms.